In this video, we'll talk about how to evaluate and simplify rational expressions. Here we are given the rational expression x plus 4 divided by x minus 7. For this rational expression, we are given some x values of -2, 5, and 7. So in order to evaluate the expression, that simply means we are substituting these given x values back into the rational expression. So starting with x value equal to -2, that would look like -2 plus 4 divided by -2 minus 7. So in that numerator, -2 plus 4 makes 2. -2 minus 7 makes -9. So when the input is -2, the output is -2/9. We have a solution. Using the x value of 5, we substitute 5 for x. 5 plus 4 is divided by 5 minus 7. The result looks like 9 for the numerator and -2 for the denominator. So when the input value was 5, the output is -9/2. Finally, we're using the x value of 7. So our replacement for x is 7. 7 plus 4 divided by 7 minus 7. The result in the numerator is 11. The denominator makes 0. So what happens when the input is 7? 11 divided by 0 is undefined. So we don't end up with any solution here. So recall that division of 0 is undefined. And that becomes something very important for us to talk about when we have a rational expression with a variable in the denominator. So we would not want to allow the x value to equal 7. We would call that a restriction. That simply means that x cannot equal 7 because the result would be an undefined amount. So we need to talk about restrictions on solutions. Recall that the x value of 7 resulted in the denominator of this rational expression being equal to 0. This example illustrates that variables are restricted to values that do not make the denominator equal to 0. When you find the restriction on the variable, you are then able to determine the domain of the rational expression. Remember, domain are all the possible input values. In this case, what values x may take on. Considering these restrictions becomes important when solving rational equations. We're going to find values where a rational expression is undefined. Given 11 divided by 2x plus 8, the expression is undefined when x equals a certain amount. So when we write the domain, we're going to say that the set of x such that x is a real number, except x cannot equal that undefined amount. So in order to find those values to fill in these blank spaces, we're simply looking at the denominator, 2x plus 8. Whatever x value makes this expression equal to 0 is the value that we need to eliminate from our domain. So setting this equal to 0, it looks like subtraction of 8 would be first. 2x now equals -8. Division of 2 means x equals -4. So the expression is undefined when x equals -4. The domain now becomes the set of x such that x is a real number, however, x cannot equal -4. So all we need to do is take the denominator, set it equal to 0, solve for x, and that value is the one that needs to be restricted. In our next rational expression, x minus 2 is divided by x squared minus 7x plus 10. So again, we're looking at the denominator only. It's okay if numerators equal 0, so we don't worry about x minus 2. So we need to take x squared minus 7x plus 10 and set that equal to 0. In order to solve this, since it's quadratic, we have to use factoring. So I would be looking at sum and product here. In the middle, negative 7 is the sum. 1 times 10 is the product. Factors of 10, I'm thinking of 2 times 5. 2 plus 5 makes positive 7. So if we make each factor negative, we'll still have the positive product, but negative 2 added to negative 5 will match negative 7. So I'll replace the middle. X squared minus 2x minus 5x plus 10 equals 0. We have our 4 terms. We're ready for grouping. It looks like x is in common. That leaves x minus 2 for that other factor. That means x minus 2 needs to be the factor for the second group. To fill in the gap, we're trying to match negative 5x. So negative 5 times x will match, and negative 2 times 5 will match the 10. To factor our greatest common factor out, we have quantity of x minus 2. The other factor is x and the minus 5. Set each factor equal to 0, and then solve each of these linear equations. So when I add 2, I'll get x equals 2. When I add 5 on this equation, I'll get x equals 5. What we just found are the restrictions on our denominator. So the expression is undefined when x equals 2 or 5. So the domain must be the set of x such that x is a real number and x cannot equal 2 or 5. So the type of factoring needed to determine these answers will vary. Sometimes you don't have to factor at all. But once you do factor, you'll use the zero factor property, solve for the variable. Those values you end up with are the values that are your restriction.